Hello everyone and welcome to Cosmos. Today we cross the rocky planets and across the asteroid belt to talk about the giant Jupiter. Jupiter is the fifth planet from our star. It is 778 million kilometers away from our star. It orbits near the belt of asteroids, orbiting. In fact, most of its moons are captured asteroids due to its immense gravity. Unlike the planets that we talked about earlier, Jupiter has no solid surface. It is made mostly of hydrogen and helium. It is named after the king of the gods in Roman mythology, Jupiter. Jupiter is the largest planet in our solar system. It is so large, in fact, that it can be filled with 1,300 Earths. It is 139,820 kilometers wide. It is also supermassive at 320 times the mass of Earth. It is the second most massive object in our solar system, second to the Sun itself. It's made of the same stuff as our Sun. Although large here, it's actually below average for a gas giant. Jupiter's composition does contain layers. These are very thick and different from Earth's, however. They are gaseous instead of solid and are thick and deep. There are multiple features too, and the layers are super turbulent. It's made of 75% hydrogen and 24% helium. Its stratospheric atmosphere has 4 layers, each with different temperatures, pressures, and compositions. Its thermosphere contains aurora, but its temperature can be as high as 730 degrees Celsius. Its stratosphere, where you find hydrocarbon hazes and with a temperature of minus 110 degrees Celsius, and its troposphere with dense water clouds and its temperatures of minus 110 degrees Celsius. As we go down, pressure increases and gas turns to liquid. This gas to liquid layer extends 7,200 kilometers deep. Below that is so pressurized that hydrogen turns into a metallic liquid. Hydrogen behaves like a metal when put under high pressure. It can be up to 20,000 to 60,000 kilometers deep and is one of the reasons for Jupiter's strong and amazing magnetic field. Finally, beneath that is the core, which is the densest of all the layers. It's a hot, soft ball of metallic hydrogen and super small. It is super powerful, generating a magnetic field that is so big that it extends thousands of miles beyond it. We don't actually know what's inside it, but we can guess. When you look at Jupiter, you notice that it has swirling stripes across it. They can be different shades of beige, brown, or gray. They are actually floating clouds of water and ammonia over the hydrogen and helium of Jupiter. The thick lighter bands are called zones and the darker ones are called belts. Also, the zones move in the direction of the rotation of Jupiter, while the belts move opposite to it. They are caused due to winds, composition, and temperature differences. These bands are also thick, extending up to 3,000 kilometers deep. Other than the bands, you find strong storms. The most famous one is the Great Red Spot. This is a massive storm the size of one Earth. It spins up to 644 kilometers per hour and is the oldest storm still ongoing after more than 150 years on it today. It is an orangish color. It's actually gradually shrinking and will disappear soon. Galileo Galilei observed the spot with a telescope. This is not the only thing he discovered, however. Jupiter has such immense gravity that it has 95 recognized moons. Out of these moons, only 57 are named. Most of these moons are tiny and irregular, with only 4 being round and big. The number increases every few years or so. These 4 round moons were first seen by Galileo Galilei and are called the Galilean moons. They're all interesting in their own way. Ganymede, the largest moon in the solar system, is so large that it's larger than Mercury. It's a rocky world with lots of underground water and is also the first known moon to possess a magnetic field. It is so big that if it orbited our Sun, it would be a planet. And there's Europa, which is the smallest of the Galilean moons and is the one with a large underwater ocean beneath the ice sheet with brown arcs caused by Jupiter's gravity. And then there's Callisto, with the oldest surface with craters, cracks, and dust more of any object. It even has the recently discovered layer of ozone. Finally, Io, the most geologically active moon with thousands of volcanoes shooting out springs of lava every day. It can even be seen from space. It has the highest density of any moon. The next biggest moon after that is Himalaya, only 140 kilometers wide, and then Amalthea at 83.5 kilometers wide. Before we learn more about this planet, we should note that this gas giant is unusual in this universe, as instead of being large and flaming, like most, it is cold and a bit smaller for a gas planet. One theory is that Jupiter was much closer to the Sun billions of years ago, along with Saturn, Uranus, Neptune, and a theorized fifth giant. Slowly, Jupiter would move outwards towards Saturn because of its gravity, and would eject the fifth giant, displacing the orbits of multiple trans-Neptunian objects. Jupiter is also the one that cleaned the dust that was present once beyond the asteroid belt with its gravity. The migration of the gas giants is what took them to their current places. This theory, called the Grand Tag, explains many things about Jupiter and its surroundings. Jupiter is the fastest rotating planet, with its day being less than 10 hours long. Because of this, you can see that Jupiter bulges at its equator even through an ordinary telescope. It is tilted at just 4 degrees, the smallest of all planets. It takes 12 years to orbit the Sun next to the asteroid belt. Its L4 and L5 groups of asteroids, known as Trojans, also orbit along with it. It has almost no seasons, each lasting 3 years. But they are very subtle. Its atmospheric changes, however, are extreme and way more turbulent than Earth. You can also see aurora caused by high-energy electrons colliding with atmospheric gases at the poles. They are bright blue rings that appear temporarily. Jupiter's magnetic field is the strongest and largest of all planets. It extends up to 7 million kilometers and almost to the orbit of Saturn in the opposite direction. Compared to Earth, its movement is 20,000 times faster. It is mostly produced by the metallic hydrogen and center core of Jupiter. The magnetic field shields its moons from solar flares. There have been a few missions to Jupiter, which is how we got amazing images and data on Jupiter. Almost all of them were sent by NASA, and the first spacecraft to reach Jupiter was Pioneer 10 in 1972, and then Pioneer 11 in 1973. Together they collected data on the moon's magnetic field and the best photos at the time of Jupiter's red spot. Later in 1979, Voyager 1 and 2 passed Jupiter, and Voyager 1 in particular took 18,000 pictures of Jupiter in color and multiple photos of Io's volcanoes, Europa's surface, and on the moon's Callisto and Ganymede. After that, in 1989, Galileo was sent as the first spacecraft orbiting Jupiter, and it detected the storms there and sent data about the magnetic field of Jupiter. Afterwards, Juno took more data on the 4 thin rings and became the second probe to orbit Jupiter in 2011. Spacecrafts like Ulysses and New Horizons take gravity excess to fly faster, and it's a very important tool that we use. Its gravity also shields us from asteroids. Future missions also include JUICE, or Jupiter Icy Moon Explorer mission, to discover about Jupiter's moon, and Clipper, which will explore Europa. As humanity's understanding of Jupiter deepens through ongoing research and missions, the planet continues to awe and expand our knowledge on our solar system and our universe as a whole.